Good afternoon, students. We continue our discussion. We are revising chapter motion. In last class, we have discussed about rest and motion, distance and displacement, scalar and vector quantities. Today, we will discuss about uniform and non-uniform motion. So, what is uniform motion? To understand the concept of uniform motion, a table is given in your book, NCERT book, on page 100. It is table 8.1. You look at the table. In one column, time is given. You see after every 15 minutes, the time interval is 15 minutes. In left side, 9:30, 9:45, 10, 10:15, 10:30 am, like this. And then another column, distance traveled by object A in meter, and in third column, distance traveled by another object B in meter. So look at the time and the distance traveled by object A. You will find that after every 15 minutes, the object covers equal distances, and the distance is how much? That is 10 meter. At 9:30, distance traveled by the object is 10 meter. After 15 minutes, that is at 9:45, it covers another 10 meters, so total distance is 20 meter. At 10 am, it means again after 15 minutes, it covers a distance of 10 meter more, so now total distance is 30. So you will find that the distance traveled by the object are equal in equal intervals of time, however small these time intervals may be. The time intervals may be small or big, but the distance traveled by the object is equal in equal interval of time. So if an object travel in this way, that it covers equal distances in equal interval of time, then its motion is said to be uniform. Now, definition, so far definition is concerned, I am not going to write the definition again, because earlier you have written about it. So you write or you listen to me that if an object covers equal distances in equal interval of time, however small these time intervals may be, then its motion is said to be uniform. So must learn this definition of uniform motion. Then most of the time we perform non-uniform motion. For example, if you are just traveling in a car in a crowded street, you will find that the speed of car is not constant. Sometimes it increases, sometimes you have to apply brake. So the distances covered by the car is not equal in equal interval of time. So just opposite of it, if an object covers unequal distances in equal interval of time, then its motion is said to be non-uniform. So again look at table 8.1 and the distance traveled by object B in meter is given. You see at 9:30 am it covers a distance of 12 meter, 9:45 19 meter, 10 am 23 meter, 10:15 35. So if you will subtract the distances, it means 19 minus 12, it will be 7. 23 minus 9, how much it will be? 4. 35 minus 23, so it will be 12. So these distances are not equal in equal interval of time. So the object is traveling with non-uniform motion. So these are very important definitions, what uniform motion is, what non-uniform motion is. Then how we can measure the rate of motion, isn't it? Because different objects may take different time to cover a given distance, isn't it? Different object take different time to cover a given distance. Why they take different time? Because the rate of motion is different. Some objects move fast, so they cover the distance in less time. Some are moving slow, so they will take more time to cover same distance. So how we can measure this rate of motion? Now to measure rate of motion, we measure the total distance traveled by the object in unit time, how much distance it traveled in unit time, and that gives a definition of another quantity, that is speed. So speed the another important quantity is speed. It measures the rate of motion. That is distance traveled per unit time. That is distance traveled per unit time. How much distance an object covers in unit time, that is the speed of the object. And as you know, SI unit is meter per second. Then we have a concept of average speed. What is the average speed? Now I am reading the last paragraph of NCERT book, page 101. To specify the speed of an object, we require only its magnitude. Yes, in last class I have discussed that scalar quantities are those quantities which are completely described by their magnitude. And in example we have written speed. The speed of an object need not be constant. In most cases, object will be in non-uniform motion. So generally all object performs non-uniform motion. It is very difficult to maintain a constant speed generally. Therefore, we describe the rate of motion of such object in terms of their average speed. Therefore, we are calculating the average speed of the object. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. So, average speed is the ratio of total distance traveled by total time taken. So must remember these definitions and their SI unit. Obviously SI unit is same for average speed also, that is meter per second. Then we have concept of speed with direction. So when we are talking about direction, it means we are talking about vector quantities, isn't it? So the rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. So the quantity which specify both the aspects, isn't it? The rate of motion with direction is known as velocity. So velocity is speed with direction. Speed with direction is called velocity. So the formula now, velocity is vector quantity. It means direction is added with it. So when we have to write a formula for it, we will write velocity is equal to displacement by time. Velocity is equal to displacement by time. Now velocity of an object can be uniform or it may be non-uniform, it may be variable. It can be changed by changing the object speed. I am reading another paragraph, page 101, speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. So we can change velocity either by changing the speed or either changing the direction or both. We can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculated average speed. In case of velocity of the object is changing at a uniform rate, then average velocity is given by arithmetic mean of initial and final velocity for a given period of time. So, if the velocity of an object is changing uniformly, then we can calculate average velocity, and average velocity is nothing but arithmetic mean of initial and final velocity. U stands for initial velocity and V stands for final velocity. And we are saying that the object changes its velocity uniformly. It means suppose when it starts moving, its velocity is simply 5 meter per second. But after some time, suppose its velocity is 40 meter per second. Then U is 5 and V is 40. So if you have to calculate the average velocity, you must add initial and final velocity and divide it by 2. That is arithmetic mean of these two. Now there is no change in unit. All have same unit because they are a ratio of distance by time. So here the same unit, SI unit, velocity meter per second, and average velocity has also same unit. Now these concepts are very important, children. What uniform motion is, non-uniform motion, speed, average speed, velocity, and average velocity, isn't it? Now we will discuss the some numericals based on these topics. First, we will discuss the questions given in our textbook, that is on page 102. Question number 1 is distinguish between speed and velocity.